Hello, welcome to our presentation. In this video, we present an Eclipse plugin IPC to complete a statement at real time. This slide shows the functionality of IPC. Assume that a user is editing a Java file in Eclipse. When he wants to let the IDE write codes for him, the only thing he needs to do is to press the hotkey of the code completion. Then a dialog containing the suggested codes will appear. Just press the direction key and the enter key to select suitable codes. This slide shows the architecture of IPC. The training data, which contains raw Java codes, will be transformed to our predefined IR. The IR will be trained into language model. When predicting statements, the codes to be completed will also be transformed to IR. Then the predictor will predict the sequences of IR tokens using the default mechanism of language models. Here shows a sequence of 3 IR tokens, which may be predicted by the predictor. The synthesizer is responsible for generating Java codes based on a sequence of IR tokens. Reasonable statements will be appended to the final result. What's more, to enhance the prediction accuracy, the context searcher, which integrates fuzzy matching mechanism to search for similar code blocks, will be adopted by the predictor. Here shows the IP address of the machine on which the AeroSpike database is installed. Our language model is stored in the AeroSpike database. Users need to set the IP address of the AeroSpike database in the preference page offered by our plugin. Then we use some cases to demonstrate the functionality of the plugin. Note that in all cases, the codes which have been commented out are the expected codes. Among codes recommended by our plugin, which are prefixed by white apple icon, the lower the position, the higher the priority. In these cases, we complete codes statement by statement. We can see that many relative statements could be proposed at one time. In many cases, the suggested statement in the lowest position with the highest priority is the expected. However, there are also many cases the expected statement is the fourth or even fifth candidate. Sometimes the codes recommended by the plugin are exactly right, and sometimes they are not. The error often happens when predicting numbers. To predict an integer which is consistent with the context is difficult, let alone floats or doubles. Our plugin can handle unseen variable names. If we change names of variables at runtime and comment out the following codes, we can see that the suggested codes still match the expected codes exactly. This example also shows that the plugin can predict the very long statement very properly. In the final stage, we make an interesting experiment. We insert many noise statements into the context to see whether the plugin can predict the right statement. We can see that even the context has been confused by some evil purpose. We still get good results. The recommended code is the same as the following code which is commented out. The results of other completions are similar to what we demonstrated earlier. Thanks for watching.